Hello again. In our last video, we learned that a graph can have no x-intercepts, one x-intercept, or multiple x-intercepts. Now we are going to include or introduce another important idea. That idea is symmetry. A graph has symmetry when one part of the graph reflects another part in a predictable way. We will focus on three types of symmetry. We have x axis of symmetry. We have y axis of symmetry. And we also have origin symmetry. So what this means is you can have an x-axis of symmetry, a y-axis of symmetry, or even an origin of symmetry. So let's begin with y-axis of symmetry. So a graph is symmetrical about the y-axis when the left side of a mirror image, when the left side is a mirror image of the right side. So for example, the y-axis of symmetry. Suppose you have the point 3, 4 as the y-axis of symmetry, and that's on the graph. If the graph is symmetrical about the y-axis, then the point -3, 4 must be on the graph. That is, if it's symmetrical with respect to the y-axis. So suppose I sketch a graph. We have our y, we have our x. Well, the point is 3, 4. So I'm just gonna, let's just say this is 3 and this is 4. So that point exists here. So if it's symmetrical with respect to the y-axis, then that means the point -3, 4 is where that point would lie. Notice it's like a mirror image across the y-axis. Another way to look at this is if you have x, y, and it is symmetrical with respect to the y-axis, then that means you would have the -xy as well. So notice what changes. The x coordinate changes sign. The y stays the same. Now let's look at x axis of symmetry. The x-axis of symmetry is as follows. If you have the point 3, 4 on a graph, if 3, 4 is on a graph that is symmetrical about the x-axis, then the point 3, -4 would be on the graph. Just to give you a visual. We have our y-axis, our x-axis. If you have the point 3, 4, again, 3, 4 would be located here. If it's symmetrical about the x-axis, that means it's reflective across the x-axis. Then you must also have -4 that occurs on the graph. So notice it's a reflection across the x juxtaposed to a y-axis of symmetry being reflective across the y-axis. Okay. We can also look at this as xy tends to x -y. So this time the x coordinate says the same or stays the same, and the y coordinate changes sign. Finally, when we think about the axis with respect or symmetry with respect to the origin, if the point 3, 4 is on the graph, then -3, -4 is also on the graph as well. So let me show you the visual. We have our y, we have our x. So 3, 4 would be located here. If it's reflective across the origin, notice the origin is here, across the origin, then that point would be here. So notice reflective across the origin, reflective across the x-axis, reflective across the y-axis. The way this would look is x, y tends to -x, -y. So both coordinates change sign. So again, this, when we are thinking about y-axis symmetry, we go from xy and it tends to -xy. When we're thinking about x-axis of symmetry, we go from xy to x -y. When we're thinking about the origin symmetry, we go from xy to -x -y. In the next video, we will use algebraic tests to determine whether an equation has x-axis symmetry, y-axis symmetry, or origin symmetry. Thanks for watching.